the Department of Computer Science students and therefore didn't have DCS account. We followed that up by asking the support team to provide accounts for all those students. So we collected together a list of non-com students and sent them forward to the DCS support team. I hope to hear from them soon. If you're unable to complete the building a local website and CGI program tutorial in time, don't worry so much. I mean, watch over a friend who does belong to the department who can do that. And we'll soon be moving on to the cloud infrastructure, which you'll have access to in any case. And I will start issuing accounts to teams at the end of this week. So I've now got the accounts, just got them the other day, and I'm going to start giving them out to me. So I guess this means you need to make sure you're signed up in your pair, in your team. I got something like another 20-odd students who aren't yet in teams, so please remember to do that. At the end of this lecture, if you don't feel you know anyone to be a pair partner, just collect outside the hall and sort of say, I'm looking for a team partner, and we'll try we'll find someone else who needs one. Okay, today we're starting to get a bit more technical about cloud computing, about web services, and so on. So if you remember from the first lecture, we were talking about how cloud computing isn't a number of earlier things. We're now going to describe what some of those earlier things do and how they support cloud computing. So we're going to look at what a web service is, one of the foundations of cloud computing. And so we'll have a look at how to build a cloud platform. We're going to look at HTTP, the protocol that's used on the web, and the idea of application servers. We're going to look at different technologies that have been used to build things like this, which includes CGI scripts, and things like active server pages if you're from a Microsoft environment, JSP if you're in a Java environment, Java servlet, JavaScript. And then we'll have a look at what actually goes on, what is exchanged when you interact with something over the web. We'll look at the hypertext transfer protocol, HTTP. Look at a request-response cycle, different methods of communication, different types of encoded data, and various response codes that you could get back, which I'm sure you get to know very, very well as you try out your own service, particularly the error codes that come back. Okay. So if you want to build a cloud platform, what does it take? Okay, just imagine you're starting from scratch. What do I need? Well, first of all, you need some virtual machine. For example, the Open Nebula VM that we will give you. You need an operating system on top of that, for example, Linux. You'll need a web server with the hypertext transfer protocol, for example, the Apache web server. You'll need an application server that is able to execute user-supplied applications. For example, this thing called Tomcat. And you'll need suitable software to put inside your application server. For example, Java servlets. And so we'll be covering all of the stuff in this stack. So this is the sort of technical bundle that you need to get your head around. Now, the way in which the current lectures are going to go, so it's that we're getting more into the more technical side. This lecture, we're going to focus on what web servers are and how HTTP works. And then in the next lecture, which is Friday morning, we're going to focus on application servers and Java. And so we're going to be looking at Java servlets coming soon. Then later on, we'll focus on how to improve the presentation of your platform, various applications that you could install on it, databases that you could put on the back end, and so on. So that's the order in which we're going to look at stuff. So here is a simple diagram showing how a regular HTTP web server works. Something like Apache. You have a number of client browsers here, and these are sending in requests for web pages to the web server. And the web server talks to some data storage at the back here to fetch the web pages and serves them up to the various browsers. So on a web server, you're limited to fetching or storing pages. And the kinds of web page that you serve up are static. That is, they're pre-written, they're saved, they're just simple files. They don't have anything dynamic attached to them. Now, an application server is different. It has this extra container inside it, which is a special environment for running maybe user-supplied software as various kinds of web applications. And so, as before, the processors send requests. Possibly they send some input data. Input data, for example, could be the contents of a submitted web form. And then the web app would perform some arbitrary kind of processing inside this container, and then the application server would collect a web page, but then the web app here would insert some dynamically generated response into that web page. So we say that it serves up dynamic web pages. So you've got this sort of thing going on instead. Dynamic web content is generated via a sort of chain, something like this. It's critical for any kind of web service, any kind of cloud service. The user sends in its request, it goes as, say, a web form like this, passes through the internet, goes to the application server, some piece of application code, typically a Java servlet, executes here, generates something which gets sent back via the internet as a dynamically formatted HTML page, which is then seen by the user. So the difference really in what we do with this is we have dynamic web applications instead of serving up static web pages. That's the difference. Now that we know what the strategy is, or what the goal is, what are the different strategies to achieve this? One method is CGI programs, which we've been talking about and we'll look at in Friday's lab again. These are sort of arbitrary programs that you can trigger at the back end of some web application. Server-side scripts are certain kinds of script programs running inside the server, if your server provides them. Something called active server pages is where you embed server-side code in compiled web pages. So you submit web pages that have a certain amount of server-side code in them. Java servlets are slightly safer. They're ways of extending the capabilities of the server inside a ready-made container for storing these extensions. And JavaScript is a more recent ability to extend the capability of the client, which is portable but insecure, and there is now JavaScript operating on the server side as well, but most people using JavaScript are using it for the sake of the client-side processing that you do. We'll look at some of these in a bit more detail. First of all, the CGI stands for Common Gateway Interface. CGI is a very overloaded acronym. In the film industry, CGI stands for computer-generated imagery. So there are various different interpretations of CGI. But when we refer to web processing, CGI stands for Common Gateway Interface. And it's the, you might say, the lowest common denominator standard for communicating with a program behind a web page. So it's a kind of protocol for activating arbitrary programs on your web server. And programs can be written in any language. Typically they're written in scripting languages which are interpreted, such as Perl or Python or Ruby or whatever. And the execution model for a CGI script is something like this. The web server intercepts various requests. Then the CGI program at the back end processes each request and generates the output page, the web page that comes back to the user. The thing about CGI is you start up a whole process environment and in which to run your programs on every time you send a request. So we say that it's a bit resource hungry. So because we have to start up the entire equivalent of a sort of programming environment that's going to run your compiled program. And it's relatively slow for this reason. When your CGI program is running, it is a completely self-contained thing. It doesn't communicate with anything else. It doesn't communicate again with the web server or with any other CGI programs that are running on the same web server. So it's a kind of self-contained unit. It does whatever it does, and so that's another aspect of CGI. But simple CGI programming is often a very useful way to learn how to develop interactive web applications, because you can write very, very simple back-end programs that kind of demonstrate to yourself that you've succeeded in order to generate some dynamic data that wasn't just stored as a static web page. So this is why we're learning how to do this in the lab. So we learn, for example, that the programs have to be executable, publicly executable. The web pages have to be publicly readable, and you learn a little bit about getting your file permissions right so that these things work. Here's another approach, less popular now, server-side script. This is where various request URLs, the handlers that you connect to on the internet, are mapped to certain scripts executing inside the server's main process. And there are various modules supplied by certain web server providers. So there's mod Perl for Perl scripts and mod PHP for PHP scripts, which you can install inside your Apache web server. These are lightweight in contrast with the CGI's heavyweight process, because the Apache scripts are going to be executed inside an already running or loaded software environment, so there's not this process of loading up the software environment. But the scripts are interpreted, and the scripts are whatever is predefined, you see. The server will activate its scripts when the server is first started up, and then upon first request for that script. Each URL request will be served by a particular script, and afterwards that script becomes free again. The scripts are run in a sort of interpreter, rather like a Perl interpreter or a Java bytecode interpreter, inside a special container. And usually this cannot crash the server, because the scripts that you have available are a limited set of extensions that are provided by the web server, Apache. Active server pages is something else. Has anyone used Microsoft ASP? Some of you may have come across it. Anyone? Okay, no one's ever used it. Okay. They're web pages with embedded code. So it's your web page is in HTML, the hypertext markup language, but there are various extensions that allow you to insert small snippets of program code. And the code parts are typically written in either Visual Basic Script or JScript, which is a sort of Microsoft version of JavaScript. The JSP, Java Server pages, may look similar, but actually it's different. It's a servlet solution in disguise. We'll explain how it's different from ASP. So ASP is a web page with small pieces of code in it. The execution model is this. The URL has an active page, so the extension ends in .asp for active server page rather than .html. That means that the web server can identify that this is a special kind of web page with some embedded code. Then what happens is that the web server parses and compiles and executes the ASP script before returning whatever HTML this produces back to the client. The script is loaded and compiled the very first time you request it. Thereafter, the backend, the program that it represents, stays resident inside the web server, so subsequent calls to activate it will be much quicker. So it executes more efficiently. So that's active server pages, which is a solution where you have web pages with embedded code. Now Java servlets is the approach we're going to be using. And Java servlets are small pieces of Java that extend the capability of the web server. And they're a safe and portable extension. Through Java servlets, one of the advantages is you have access to all of the Java language and all of the APIs of the various libraries of Java, and it's fairly easy to develop servlets once you understand how they work. The execution model is like this. A web server compiles and launches various servlets that you provided at startup. There's also a separate thing called Java server pages, which we'll talk about later. But a Java server page, which looks a little bit like an active server page, but just with a Java flavor, it actually isn't a script. It's something that compiles to a Java servlet upon its first request. So JSPs probably fit into the same group as this group here. The idea is this, that once your servlet has been compiled and is there, it services multiple requests over its lifetime. So each servlet has a certain job to do. It's efficient, so separate requests could be handled in different lightweight threads. So servlets can be multi-threaded. That means they can handle parallel requests together. And servlets are scalable, so you can ask your servlet container to deploy multiple copies of the same servlet if you anticipate having many requests to do this particular thing. So you could do that and do that on demand. And then the other thing, of course, is that servlets, by being by nature pure Java, can interact with the web server, with the client browser. They can interact with other servlets as well. So you have this nice way of communicating between different parts of your sort of deployed web application, which is a collection of servlets. So that's the Java servlet solution, and very well understood by now. JavaScript was slightly newer. So JavaScript was brought in as a language. It was named after the Java name just in order to piggyback on the fame of the Java programming language. It has absolutely nothing to do with the Java programming language. So JavaScript is a completely different language. They just stole the name in order to try and increase its popularity. And what JavaScript, an interpreter, is built into most modern web browsers. And the initial intention of JavaScript was to extend the capability of your client web browser. So in certain HTML tags called script, you can embed a certain amount of code. And JavaScript, as the languages have developed, there's Node.js, there's AngularJS, there's lots of different flavors of it. You ended up being able to write quite complex programs, sort of embedded or hidden inside web pages, which you could then download from the web server, which would then compile on your client side and then execute inside your client web browser. So that's a different kind of execution model. It's got JavaScript has various flavors, such as imperative programming flavor, functional programming flavor, object-oriented flavors as well. The execution model looks like this. The web server delivers some HTML page with some embedded JavaScript. It runs in interpreted mode on the client browser. JavaScript could interact with the document object model of your web page, so it could read and write values. It could modify the web page you view in your screen. It's useful, for example, for data input validation. You can write client-side routines that check the quality of your data before it gets posted. It's useful for special visual effects. Sometimes people wanted to have JavaScript so they could make their buttons do funny things when their mouse rolls over them. You know, they could make them shine or depress or this sort of thing. But the thing about JavaScript is that all the code is sort of stored as is in the web pages, and it can be intercepted during delivery to you, so it's not very secure. And I've worked with German companies that run cloud-based systems, and they all use Java and Java servlets and Tomcat, because all of the executing code is controlled by them. It's on the server side, sitting in a Tomcat container. And then I worked with a Greek company that ran a sort of rich client model based on JavaScript. Their server was just a simple back-end database with create, retrieve, update, delete, what we call a CRUD server, C-R-U-D. And they spent all of their time doing penetration testing, that is, trying to see whether or not by injecting code into the downloaded JavaScript, they could actually cause some corruption to the back-end database. So they had a lot of trouble with security. So although JavaScript is very, very popular, I want to say be wary of server-side JavaScript as well, because it's not especially secure. Okay, so those are the different mechanisms that you can use. We're now going to dig in a little bit more into how a client web server communicates, so how a client browser communicates with a backend web server, and how this works. So we're referring to the Hypertext Transfer Protocol, known as HTTP, and this is the sort of common language for communicating over the internet, particularly for web services. Okay, so in particular web services. HTTP is a kind of syntax for sending and receiving World Wide Web related data. And as it turns out, HTTP is just one of several important internet protocols, so we'll have a look at what some of these protocols mean. Here's a bunch of them, internet protocols. So HTTP stands for Hypertext Transfer Protocol, and it handles web browser server communication. So it's a language for doing that. There's another one called SMTP, Simple Mail Transfer Protocol, and that is for handling email, client to mail server communication. So you may have come across SMTP mail services. There's FTP, which is File Transfer Protocol, and this is another protocol for uploading or downloading file data directly to a remote machine. There's something called SSH, Secure Shell, which is another protocol for handling secure client-server communications. This involves using public-private keys, as we described in the last lecture. And then sitting underneath all of this, there's TCP/IP, which is the Transmission Control Protocol or Internet Protocol. And this is the basic protocol that handles the sort of end-to-end transport of bytes on the network and unpacks the bytes for you. So the Internet has a number of these languages which it uses, and you'll be using a number of these as you go along. You'll be using Secure Shell, HTTP, you'll implicitly be using TCP/IP. How does HTTP work? Well, it has a sort of request and a response sort of action. The client sends a request, the server sends a response, and nothing is remembered after that. So it's a simple request-response loop. Here's an example of a request. It's a command get with some sort of path to a file and some explanation of which version of the HTTP protocol to use. Here's a response, which is saying which protocol version I'm using, and then some code which indicates the outcome. That happens to mean that everything happened okay, it was all fine. So the syntax is a bit like this. The request that you send, you can think of it as a request method or a command that you want to send, is the first thing that you send. Then there are one-to-many optional headers describing the content of the payload that you wish to send and receive. After the headers, you always have one blank line separated. So if you're generating requests by other programs, you have to remember to insert the blank line. Then after the blank line, so the stuff before the blank line is everything to do with the sort of metadata about the request. After the blank line is the data payload, which could be, for example, all the data that you submitted in a web form, all of the fields that you filled in, and that would be sent as a separate payload after this blank line separator. And the response is similar. It consists of some acknowledgement, which also includes one-to-many optional headers describing what the payload is that's being sent. Then again, there's a single blank line sent in the response, and then the data payload. So the data payload could be, the text of an HTML web page, for example. And again, this means, of course, if your programs are generating responses, you need to generate the right kinds of headers, you need to generate the line separator, and then you need to generate something that looks like an HTML web page. Okay, that's how it works. We'll look at each of those in a minute. What I'm going to do now is start sending the attendance sheet. I've got a pen here, I don't know how long it's going to last, but if you please look up your name and sign the fact that you are here today, that would be good, thank you. Okay, that will be going around. We'll assume everyone's here who don't hear. Here is an example of an HTTP request and response pair. So you can see we've got a bunch of stuff here. In this request, there is no data payload. Okay. So you can see there's the request. It's saying get something. It's giving a path to a file and a protocol. The response here is saying I'm using this version of HTTP, and the response succeeded. 200 OK means good. Then after the line space, there's some HTML code. I've elided the rest of the contents of this HTML file there, so the dots there mean there's lots of other stuff there that I've just missed out for the sake of presentation. So what goes into the request? Well, the first bit, this thing, get, is what's called an HTTP method. It's one of the sorts of commands or types of commands you can send to the server. There are a number of these different commands, and mostly we'll be using either get or post. The intro.html that identifies a web page to serve. So starting with / that means it's under the root public HTML directory. Then HTTP 1.0, this is telling the server that that's the version of the HTML protocol supported by the client. So that says, I only run HTTP 1.0, I don't run version 1.1, for example. Then we've got a bunch of headers. For example, down here, accept. This line represents what types of content, what types of payload this browser can accept. I can accept images in the GIF and the JPEG format. I can accept text of any kind and general files of any kind. These are called MIME types, which we'll describe on the next slide, these different types of data. Another header down here says, keep alive this connection, please. So that's sort of saying, keep alive the internet connection with me, the file connection, because I expect to want to be interacting with you again, for example. So that's a request for a persistent connection. And there are various other kinds of header notion there. Here, for example, accept language NGB says English, British English, please. And this is accept encoding gzip, allow me to download data in the GNU zip format and stuff like that. So there are a number of these things that can be sent. So that's the general form of the request. Here's the response. It comes back. And HTTP 1.0, it's saying this is the version that the server supports, and so we're happy, we agree on which version of HTTP. 200 OK is a response code indicating success. There are various response codes, some of which indicate different kinds of problem or failure. The content type, again, is telling the client browser what the content type of this returned document actually is. So you can see it's text/HTML. So it's a web page, right? It's telling you it's a web page. Then there's the line space, and then there's the payload. Notice though that the connection, it sends back a header connection closed, which says, despite the fact that you requested a persistent connection, I'm not giving you one. So the server was not set up to do that. It says, I'm closing your connection. This server does not support persistent connections. So this is just another way of the server telling you exactly how it's going to behave. And here's a complete example of sort of request and response, I think. Here we go. Yeah. So here's the user having typed in and is trying to connect to an internet source connected to this place. And then here's the command. He's typing in get, trying to get this, the main page, using HTTP 1.1, host is this, and then space, and then the request is gone. Here's the response headers. All of this blue stuff is all the headers, and it came back saying, okay, here's the date, I use the caching server, It was powered by PHP, all sorts of other things. It was English, various options. The file was last modified on this date. The content length is this number of bytes. Content type is text. I'm using character set UTF-8 and all sorts of other stuff. And finally, connection close, and then a space, and then this is the actual web page. Okay, so you've got all of that back as plain data, and then at the end it just says connection closed by foreign host, and so we're back to the command line. So this was a guy who was sort of sending an HTTP request, as it were, by hand from the command line to a particular web server where he logged into using Telnet. So that's an example. So we described a GET method, which was designed to fetch a web page. There's a number of other methods that you could use. So the GET command is designed to fetch a web page. You supply the data with the URL. Head works rather like GET, but it just fetches the header information. So you can use this to check, for example, the document size, when the web page was last modified, and this sort of thing. The post method is also used to fetch web pages, but any data that you send is supplied on standard input, and we'll explain the difference between that one and that one later. The post command is called post because it was originally designed to do newsgroup postings. Okay, before social media existed, things like Facebook and Twitter, the internet community shared information with each other on these forums called newsgroups, and they all had interesting names like alt-rec something or other, and you could sign up, and you could post various new updates about things you were interested in for these various newsgroups, which were moderated. And so the post command kind of persisted in HTTP, although mostly newsgroups were more or less dying to death. People are using Facebook and Twitter and MySpace and WhatsApp and all those other things instead nowadays. So that's why it's called post. But it's also used to fetch web pages, and for reasons that we'll explain later, it's the best method to use if you want to submit web forms. Okay, another HTTP command is called put. This is designed to place a document on the web server, but it's not widely supported by web server implementations. They don't like the idea of allowing people to arbitrarily upload stuff to their web server. Delete, again, removes documents from the web server, again, not widely supported. Trace is simply a way of saying submit a request and then see what happened. It's a way of sort of doing a there and back sort of trace of how the request and response work, useful for debugging. Options is a message you can send to a server to ask which of these methods it supports. And connect is so far unused HTTP command, which is reserved for future tunneling requests. So the idea would be in future something else might want to piggyback on top of HTTP, so they've got a special command that might allow that in the future. So mostly we're going to be looking at get and post. Now, there are two properties of HTTP which we actually want to emphasize. These are called safety and idempotence, so we'll explain what they mean. Okay. The notion is that some commands are intrinsically safe, other commands may not be. The idea is that get and head commands should not have any significance of taking any other action than the retrieval. So they're designed to be access only, if you like, access only kind of request. On the other hand, post, put, delete are possibly unsafe actions that can have side effects on the server. They can modify data stored on the server. Then idempotence is this idea. Now, if you think about how the internet is actually physically constructed, you've got a lot of different points between your client browser and the back-end web server. Your request is sent via various routers, and of course, routers can break, but the way internet transmission works is that your message may be routed in in several different directions, and then may be received eventually multiple times at the destination end by the server. So it's a very robust system. It's rather like ant trails. Ants follow pheromone trails, and it's really hard to stop an ant finding its way to your sugar bowl in your house because the trail mechanism is so robust. And the internet works on a very similar way. This, of course, means that the server might receive multiple copies of your request. This could be a problem. Does it mean it has to serve up your web page multiple times? So idempotence is the idea that if a certain number of identical requests are received along different routes within some tiny delta time interval, then the server should interpret those multiple requests as just a single request. So it means that multiple requests for the same thing get treated as the same request. And the server will resolve that without having to ask you whether that was right or wrong. So the idea of idempotence is that multiple requests within a tiny delta time window are treated as a single request. However, if you submit in human time the same request several seconds apart, that would be non-idempotent, and so you might have the danger of accidentally submitting the data twice. You've probably interacted with a website where you kind of clicked backwards and forwards on your web browser, and it's put up a warning and said, do you want to resubmit that web form? Okay, this is what it's asking you about in that case. Did you really mean accidentally to send that same request again? So normally the idempotence applies to multiple requests received within a tiny time frame. So again, distinguishing get and post a bit more. We're going to sort of describe what it was designed for, and whether it can send data, whether the data is visible, whether we can bookmark this in our web page, whether we can redo it. Get. The get method was designed for receiving information, for example, fetching a web page, or returning the result of a database query. That's what it's for. Contrast this with post. This is designed for sending information. For example, sending your credit card number or sending a posting to a news group. Can these methods send data? Well, both of them can actually submit data. The get method can send limited amounts of data, and in fact, if you have a web form that you submit using the get data, the input fields that you fill into the web form are appended to the URL, and they're sent as a sort of scrambled URL encoded string. You've probably seen some of these things where it says ampersand field equals value, ampersand another field equals another value, and so on. This is where your form fields or your current cookie data or something is being submitted back to the server as part of the URL, so it's added to the end of the URL. And we'll come back to that. Whereas with the post method, the form data, or whatever it is not attached to the URL. The URL is, as it were, pristine, it's not modified, but the data is sent on standard input. So this means that your program sitting at the back end of your web page is going to read some data as if the data is on the standard input channel. Is the data visible to the client? So in this case, if you use get and submitted your web form, yes, all of your form data would be publicly visible as part of the URL that you submitted. And of course, URLs can be intercepted, they can be looked at in transit. So this would be a particularly unsafe way of transmitting secret data. Whereas with the post method, the URL stays the same, it's not modified, so any node along the way doesn't read any data of yours. The data is sent separately on the standard input channel, so the data is not revealed. You can bookmark a GET request, so that means you could return back to it in your bookmarks. You can't bookmark a POST request. A GET request could be reloaded and potentially a POST request shouldn't redundant. So you see the difference, why it's better to use post. The other thing about this is, of course, using get method for input, you are limited to the maximum length of the maximum allowed URL string. So if you wish to add arbitrary form data to the end of the URL, eventually you will reach a limit and not be able to submit a URL longer than a certain string. Whereas with the post method, you can upload an arbitrary input payload, so that there are no restrictions on that. And so here at the end, we've got an example of something going on like that. So here is, let's imagine, this is the visual representation of the web form. I know I've kind of just created it for a slide, but it's got something like title, contact form. It's got a name field where someone types in a name, an email field where they type an email, and it's got a button which has submit on it. And that would have been generated by a piece of HTML that looks a bit like this. So it begins with the tag form and ends with form. Then within it, it's got a number of divisions. The first division contains a header of the fourth level header. Then we've got a division with just plain text, name, then an input field. And then into that division starts another division, plain text, just email, and a text input field. End of that division starts another division. Finally, another input field of the type called submit. Okay, so the first two, we now have these different HTML representations for different kinds of input fields, 1, 2, 3 of them. This is just plain text. So we've got an input field of the type text, and what that does is it expects you to, it produces for you a little box when you type in text, similar to this one. If you have an input field whose type is submit, then it creates a button that you can click on instead. So all of this is handled by is understood by your web browser. It understands this HTML and it will construct the right kind of form. Now there are a number of other fields. We've named the first input field user, and we've named the second input field mail, and the last one is automatically a submit field, but we put value equals submit, so the button has a big capital submit in it. Now when you click on that button, what happens? Well, the contents of your input fields are somehow going to be saved and transmitted to your destination website. And the thing that determines what happens is the additional attributes inside the opening form field here. So this is saying the action to do when I press submit is run this program called contact CGI, so a simple CGI program, and this is the HTTP method to use, get, right? Use the get method. So the HTTP request will be sent to the web server looking rather like this. It will say get, and it will then do /contact.cgi, so that's the action that we've asked. So it's going to try and run that program. And then after the question mark, there's a bunch of stuff, which is the data that was added to the end of the URL, the data that came from your web form, okay? And so the question mark sort of separates out the URL path, and then we have the data, user Johns plus Smith. So plus is being used here to escape a space there. John plus Smith, and then the ampersand character is used to say, here's the next field, and mail equals, and then we've got JB Smith, and then %40 chef.ac.uk. What's this %40? This %40 is a special character encoding for the @ character. Okay. So for spaces, you may get a plus sign, you may get a different character encoding. I think it's %20. Is that right? I forget. Well, anyway. So the entire contents of your web form is kind of encoded as a string with no spaces, of course, because otherwise it would be the end of the URL. And that will all be sent to the web server. We're using the 1.0 protocol, the type of stuff we're expecting to get back is text.html. So we say this form data is URL encoded. It's encoded in order to be transmitted as part of a URL. Certain characters are escaped. So that's right. Space can be turned into plus or to %20, and the @ sign would be encoded as %40. And then at the destination end, your program would have to be able to unscramble this kind of URL encoding. Let's show you how the same thing works using the post method. We've got our web form exactly as before. The only difference is this time the method that we want to send is post. I filled in the same data on the form. I press on submit, and the request that gets sent via HTTP looks like this. It says post, and then it gives just the plain web part, and then all the other information, the header information, and then it will send a line space, and then this data will be read by the web server on standard input instead. There it is. Same stuff, encoded the same way. So that means that the script program, contact.cgi, is expecting to read this string as part of standard input. So it does as if you were reading user data typed in at the keyboard as you would in a normal program. And that's how your program works. Okay, let's have a quick look at MIME types. We've got multi-purpose internet mail extensions. These are the different types of things. They originally developed for email attachments, hence the internet mail extension. But the two most important ones are text plain. That's if you want to return plain text to your web browser. Text/HTML if you want to return a web page. But there are loads of others. Now you've got application-specific formats. You've got image formats like the JPEG or the GIF format. You've got video formats such as MPEG and MP3, MP4, and so on. Your browser will either handle this type already, or it will prompt the user to say, I can't handle this format now, but I could, if you like, install a plugin program that will allow me to display this. So, for example, many browsers have Adobe PDF readers built into them now, so you can actually click on a PDF file and see it directly in your browser. If the content type header is missing in the returned information, then the browser will make guesses. It will use its defaults for trying to display the form of data. Then here's a collection of useful HTTP status codes. The 100 series gives a sort of provisional information, your request is in progress or something like that. The 200 series, that's what you're hoping to get. That indicates success, that you've successfully retrieved the web page. The 300 series reports redirection. It sort of says, you tried to get this page here, we're redirecting you to another URL somewhere else. The 400 series report an error on the client side, an error that you made. And the 500 series report an error that occurred on the server side instead. And here's a complete list of error codes on them. There's one or two of them that are completely hilarious, so I'll let you look up there to find out what they were. Here's some useful ones. 200 OK, that means I got this successfully. 301 means this web service has been moved permanently. 400 is a sort of bad request. You didn't make a correct HTTP request. 401 is unauthorized. That means you would need to be authenticated to be allowed to access this web page. 403, you'll get that one. That's forbidden when you try to access a web page that you've forgotten to make public. So your file permissions don't allow you access. One of you smiling. I think you've already had that game. Played that game, haven't you? Yeah. Okay. 404 not found. That means you searched for the web page in the wrong directory. Yeah. That's a good one. That will tell you if you pointed your web browser at the wrong place. 500 is a generic internal server error. Okay. Really hard to diagnose what that means if you go to 500. 501 is not implemented. 503 is the server's temporarily down. 505 is the HTTP version is not supported. Mostly if you get a 500 internal server error, this probably means that your CGI program has either raised an exception or it's done something that has internally caused the program to crash. It might mean that it's trying to return a document that's not the expected HTML or something like that. You have to be to do a serious amount of investigation if you get an internal server error. Okay, pros and cons. HTTP is really simple, widely used on the internet. I mean, it's used in what's called the REST protocol. Typically goes through firewalls, supports any data type, and it's stateless. Its request to response cycle is self-contained. So each subsequent request is complete when it's done. The disadvantages have to do with the same, right? That it is stateless. No information is retained between requests. So the notion of you logging in, the notion of you adding things to your shopping cart, all of this stuff is difficult to do through HTTP. It doesn't remember anything. There are no persistent connections, maybe no support for tracking user sessions, no support for secure transactions and rolling back, no support for security. And so these are the kinds of things that we have to build into our systems ourselves. So HTTP is beautiful, elegant, and very simple, but doesn't do a lot of those things that we've done. So where is your DCS website? You can build one under here. You can build CGI scripts there. You can point your browser to your root student directory, where this is your email ID, your proper ID, not your login name, your email ID. Where is your cloud website? You can build a public website on the cloud VM. You put your HTML files under here. You point your web browser to the IP address of your VM, which might be this, where the three ends are the last 3 digits of your IP address. So this is where you can put web pages to try out some of these web page fetching. So we need to finish. We've gone a little bit over. The web server, application server tier sits in the middle. CGI programs or scripts are an older method of running whole programs on the web server. Server-side and active server pages are slightly better since their scripts stay resident and service multiple requests. Java servlets and JSP pages are best. They compile well and integrate well with other Java APIs, so you've got a lot of programming power. HTTP is the standard protocol for servicing web pages, but it is stateless, which is an issue for all kinds of e-commerce. And the most common methods are GET for access and POST for data transmission. So that's what we've covered today. Okay, thank you. And anyone wanting to find a partner, please meet me.